So we're going to talk about counting and gambling, and we're going to do just a few problems here. So we're going to use that fundamental counting principle to analyze a slot machine. So here we have a slot machine put out right here. You can see the different columns here. It's got three things that can pop up, and we've got some lemons and oranges and cherries and plums and bars. And we're going to answer a couple of questions here. We're going to only answer 3 of them. So we're going to look at in how many different ways can 3 wheels of the slot machine depicted stop. So how many different ways can this stop? Like we get 1 from this column, 1 from this column, and 1 from here. So the first thing we have to do is we have to count. So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we have 20 choices that happen. So using our fundamental counting principle, we know that if we have 20 and they're all the same length and height, or height here, so we know there's the same amount on each one. So for the first wheel, we have 20. The second wheel, we have 20. And for the third wheel, we have 20. So 20 times 20 times 20 will get us 8,000. So there's 8,000 different ways that the 3 wheels can stop. All right, let's look at part B. So part B says that 1 payoff is for cherries on wheel 1 and no cherries on the other wheels. So the first wheel, we're looking for cherries. And then on the second wheel, we want no cherries. And on the third wheel, we want no cherries. So first, cherries, then no cherry, because that's what it says. So now we've got to go back to our wheels, and we've got to count how many cherries there are on the first wheel, because we're looking at how many we can possibly get. So as we scroll down, we can see 1 cherry, and we can see 2 cherries, and we only have 2 possible cherries. On the second wheel, we want to find how many of them don't have cherries. It might be easier to count the cherries and then subtract it from 20. So we've got 1, 2, 3, 4, 5 cherries, but it can't be cherries. So 20 minus 5 would get us 15 with no cherries. On the third wheel, we have 1, 2, 3, 4, 5, 6, 7, 8 cherries in total. So if we have 8 cherries, we want to not get cherries, so 20 minus 8 would get us times 12 with no cherries. And if we multiply 2 times 15 times 12, we will get 360 possible ways that we could win with that. All right, part C says the largest payoff is for 3 bars. In how many ways can 3 bars show up? All right, so we're back to our wheel with our 3 bars. So this will be part C. So on the first wheel, we want only bars here. So we have the first, we'll have the second, and we'll have the third. So on the first one, we have 1 bar and 2 bars. On the second wheel, we have 1 bar, 2 bars, 3 bars. And on the fourth wheel, we have 1 bar. So it'll be times 1. Well, 2 times 3 times 1 will get us 6 ways that we, for 3 gold bars. So you can notice that there's only 6 here. When we're trying to just get a cherry on one of them versus none of them, or 1 and none on these, there were 360 ways. This only has 6 possible ways for you to get this, and that's why the payoff is greater, because there's not as many opportunities for you to win it.